So the trigonometry question in the triangle ABC, AB is 6, BC is 8, and the area we're told is 12. So what we can do is just a little sketch A, B, C, for example. So AB we're told is 6, BC we're told is 8. And we know that the area of the triangle is 12. Now it says find the two possible values of ABC. Now, if we were doing this at ordinary level, we wouldn't be looking for 2. We would just be assuming that that is acute. But we understand, of course, that in fact there are 2 possibilities of a triangle like this. There can be, now, there can never be a rectangle. That can't be a triangle, because if you were to try and make it into some sort of a triangle, well, it wouldn't be. It's a quadrilateral. It doesn't have 3 sides, it has 4. But the main reason is because a triangle, the angles have to add to 180. And if you have a reflex angle, well, then you already have an angle that's bigger than 180, and there wouldn't be enough left to cover the other angles. So that's why there are not 1, but in fact 2. So you're looking at really something that's in the first quadrant or the second quadrant. So we're going to start. So the formula for area of a triangle is half AB sine C. Now, of course, there's a lot of formulas for area of triangles, but in the sense of trigonometry, it's this one. So we know that this is of course, we don't know what that angle is. We can call it the sine of B, because that's where the angle is situated in this particular case. So we fill in, well, sorry, we can fill it in. I've just filled in B for the moment, just to, or you can call it X, you know, whatever you like. But what the key thing we need to do is we need to move everything to the other side. So I might do that here. So we're going to do 12 over, we do sine inverse. So we're doing the sine inverse of this. Okay, so after we do that, we end up getting an answer and put it into our calculator. We get 30. So we've discovered that a possibility is that the angle is 30. Now, what's the other possibility? Well, because we can only work with the first or second quadrant in terms of sine being positive, all we have to do is 180 minus 30, which gives us the other possibility, which is 150. So our 2 answers are there now. We have a possibility of 150 or 30. So that's the answer to the first one. Now, in the case that the angle is obtuse, find the measure AC. So for this particular question, we're asked to assume that in fact the obtuse answer is the one that we want. So we're assuming it's the 150. This is 6 from A to B, and from B to C, we don't know what B to C. Which one are we? Oh no, we're looking for A to C. Sorry, yeah. So we're looking for A to C. So we'll just call that X, and B to C is 8. Yeah. So the one we're looking for is the A to C. So if it's not right angled, which it isn't, then we're left with either the sine rule or the cosine rule. Even if you try to go ahead and use the sine rule, you'll soon discover you don't have enough angles there. So it is going to be the cosine rule. So we take the unknown side, we let it equal the other 2 sides. Now you should be writing your formula here, of course. I'm just kind of skipping that step. So it's your cosine rule, and this ends up being what you fill in. Remember, with the cosine rule, if you're missing a side, you start with that side, and they should be opposite. The first and the last should be opposite each other in the diagram, which they are. So finally, we discovered that X turns out to be 13.5 to 1 decimal place, and the units are centimeters. We are then asked, the length of an arc of a circle is 12. So we have an arc of a circle, so kind of like a pizza slice, basically, like a sector. So we know this arc is 12 centimeters. We know the radius is 3. Theta is the angle at the center of the circle subtended by the arc. So we know that theta is the angle here. Now we're told that this is a circle, so we can still imagine that it is all within a circle, but we're only interested in the arc measurement for the moment. So just this arc measurement. So we're asked to find the measure of the angle theta. Now, if we look at our log tables, because the angle is in radians, we're going to use the formula that is L is equal to R theta. L represents the length of the arc, which we know is 12. R is the radius, which we know is 3, and theta is this angle. So it's quite an easy one. In fact, you divide 12 over 3, and theta is 4. So that gives us 4 radians, because it's in radians, as our answer. And then it says, find the measure of the angle theta in degrees. So now they're saying, okay, you know what it is in radians, but what is it in degrees? So if I want to convert, all I do is 180 over pi multiplied by the number of radians, which is 4, and that gives me 229.2 degrees. So kind of a very straightforward question, really, for our trigonometry question.